Welcome to EDU World Space.
Welcome to a new problem. This time we have a ball. It's a steel ball. So we're given a steel ball, and it happens to have a mass of 40 kilograms, or rather 40 grams. So we'll say mass of steel is 40 grams. We can change that right away to kilograms by multiplying that by 1,000 kilograms. So we have 0. Um, 0. So 40 into 1,000. Let's see what's that going to give us. It's going to give us 0.04 kilograms. So that's the weight, the not the weight, but the mass of the steel ball. It's dropped from a height of 2 meters. Okay, so we're going to call this H initial. Yes, H initial, 2.00 meters. And then it bounces off and goes all the way, bounces off and gets to a new height. This is the ball, so this is the new height. Final height happens to be 1.60 meters. So that's the final height that it's bouncing. Remember, acceleration due to gravity, G, is 9.8 meters per second squared. You can think of going downwards as positive and going upwards as negative. You can think of it that way. In part A, we want to find the impulse, okay, of the force, impulse delivered by the force. Remember, impulse is just the change in momentum, or the final momentum minus the initial momentum. So in that case, we're going to have to find the final and initial velocity. The second part is that we're given a time, t equals to 200 milliseconds. Or if you want to change that right away, you could say in seconds. This is over 1,000 seconds, and that's going to give us 0.002 seconds. Okay, 0.002 seconds. That's the time it takes to bounce off for a moment. And so in part B, we want to find what's this average force that's responsible, okay, for that change. What's the average force responsible for that change? So the first thing we'll do, we have to compute the initial and final velocity. The initial velocity is just the square root of 2g h1, and that gives us a radical 2 times 9.8 meters per second squared times the height displacement, which is 2.00 meters, and this becomes 6.3 meters per second. That's the initial velocity. The final velocity, the same type of formula, radical 2gh final. And so this is 2 times 9.8 meters per second squared, and then multiply that by the final height, which is 1.6 meters. And that's going to give us a final velocity of 5.6 meters per second. That velocity is a minus because of our direction and orientation. In the next page, we're set to compute the impulse, which happens to be final minus initial. The mass, this is final velocity. We gotta change this a little bit. We have to put in the mass. We're given the mass 0. If you can recall, if I go back, this is the mass right here. It's 0.04 kilograms. So that's the one we're going to use. So 0.04 kilograms. And then the final velocity is negative 5.6 meters per second minus 6.3 meters per second. And so this, when you plug in those numbers, you get negative 0.48 kilogram meters per second. That's, mass and the velocity. So the magnitude of the impulse, the magnitude of the impulse is 0. You gotta write that 0.48 kilogram meters per second. That's the magnitude of the impulse. The next thing that happens is we know the time of contact, and that's going to help us determine the average force. So force average equals to the impulse over the time of contact. We already have the impulse, which is 0.48 kilogram meters per second in terms of magnitude. And then the time of contact, if we go back, we find it's 0.002 seconds. So we'll plug that 0.002 seconds. And if you put in those numbers, you get that the 48 divided by 0.002, and that becomes 24,000 newtons, which you could also write as 2.4 times 10 to the 3 newtons. So like that, 2.4 times 10 to the 3 newtons. Hope you enjoyed the problem. We had to find the impulse, which is pretty much the change in momentum, 0.48 kilogram meters per second. And then we also had to find the force responsible for the average force during the time of impact. So that's 2.4 times 10 to the 3 newtons. Feel free to ask any questions. You can send any questions my way, and have a wonderful day. Okay, thanks. Bye.